Let's begin. Today's December 21st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 5, 8, 15, 17, and 19. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A takes a look at our first digit, the triangle digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing machine will let us know how many ones there are. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card C will take a look at our 3 digits, triangle, square, and circle, and the Turing machine will let us know which one is the absolute largest. Should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card D, again, takes a look at our 3-digit solution, except this time the Turing machine will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. And finally, criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. Should the sum of the first 2 digits be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card A. Okay, so the Turing machine does not approve of my choice in triangle. I did pick an odd 3, but since the Turing machine does not agree with that, it's actually informing us that triangle should actually be an even digit. So let's go ahead and type that up in our notes in section A. And we'll state that triangle is an even digit. And of course, since it is even, let's go ahead and cross out the 3 odds. Well, we've already established that triangle is even, and so we know that there can't be 0 or no evens, and I believe we can even say that there can't be 3 evens, and that's because if I knew there were 3 evens, I know there would be 0 ones. So it really comes down to either there being 1 even or 2 evens, and I do have 1 even, so that's good. It's at least one of the possibilities. And I'm trying to look at all the other solutions. So let's go ahead and test criteria card D, the number of evens. Okay, so it approves of my proposal. Notice that it does approve of a single 1, so it is true that my solution should have a single even. So let's go ahead and type that up in our notes in section D, and we'll state that the solution has a single even. Okay, now we don't know where that even, well, actually we do know where that even is. It's in triangle. So therefore, we can conclude that square and circle must be odd. Okay, oops, I almost slipped on that one. So let's go ahead and cross out the evens in both square and circle. Okay, so we are looking for a solution that is even, odd, even. And let's see. Well, since we have an even in triangle and an odd in square, we know that the sum cannot be equal to 6 because an odd plus an even is always odd. So I think that may be a good opportunity to test. Well, let's see. I'm trying to see if we've already narrowed down the sum of the first two digits to a 50-50. Would it be better to test maybe criteria card C? Because there are 3 possibilities. And if I do it now, then I'd have another 50-50 going into the 3rd round. Yeah, I think that might be the best strategy. So let's see. So currently in my proposal, I do have the circle being the largest. So let's go ahead and let's see, what can we say anything about the largest? I guess technically it could be even the even digit in triangle. That's possible. I don't think we can say it can't be even. So let's see. Yeah, let's go ahead and test criteria card C. Okay, so it is not the case that circle is the largest. So what we'll say is that either triangle or square must be the largest. So let's go ahead and type that up in our notes in section C. And we'll say that triangle or square must be the largest. And that may be a benefit also, because that if we know that triangle or square is the largest, it's not a guarantee that the sum has to be greater than 6, but it could be an indication that, yeah, it might be greater than 6. So let's go ahead and we'll conclude this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test B, inquiring how many ones there might be in our solution. Obviously, it's still outstanding whether triangle or square is the largest. And we didn't test criteria card E, comparing the sum of the first 2 digits to 6. Okay, so what if there were no ones? And we know that, so if there were no ones, I don't think square could be the largest. Or actually, let me think about that. With as a 3, that is. So if there were no ones, square could not be 3, because there would be nothing else to pick if there were no ones. Now, what if, again, there were no ones? Well, that forces square to be 5, the biggest. And let's see, there's nothing about duplicates. So yeah, maybe, again, here we're presuming that there are no ones. And let's finish that. So if it were 5, I think there would be too many ambiguous solutions, because both 2 and 4, when in triangle, when added to the square 5, that would produce a sum that is greater than 6. So yeah, so I think, well, in combination, you can't not have any ones and square be the largest. What about vice versa? Or what if we still consider no ones and triangle is the largest? Well, if triangle is the largest, that would mean that triangle would have to be 4. And again, we would have well, at least it would be a single solution. It would have to be 433 in order for, if there were no ones, there would only be one viable solution, square 4, and then triangle 4, sorry, and then square and circle be 3s. So, yeah, so I don't think, what if there were no ones? Yeah, square can't be the largest in either case. Yeah, I don't see that happening. Now, what if there were ones? Well, that changes a lot. So maybe there is a single one. And let's see which one could be the largest. Perhaps, again, I'm thinking that maybe there is a one, maybe circle. But then how would you pick? Yeah, I'm thinking that maybe triangle's the largest. And if there is a one, let's see, 4, 1. But then how do you pick between 3 and 5? Well, maybe it is 433. Let's see. Well, we are dealing with a couple of 50-50, so let's go ahead and try that out. Let's do 433. And just to double check, yes, that first digit is even. It's true that I did pick triangle B the largest, and there's a single even. Okay, let's try that out. So let's see, which one could I deduce? There are an equal amount of sums that could be less than 6 and greater than 6. So it'd be nice to perhaps maybe figure E out, and it may be either B or C that we may be able to deduce. So let's go ahead and test criteria card E. Okay, so the sum is not greater than 6. Okay, so here we'll type it up as we're going to deduce that the sum should be less than. Well, that's interesting since one or the other is the largest. So let's go ahead and type it up, and we'll say that, again, we are going to deduce that triangle plus square should be less than 6. Okay. Again, it can't be equal to 6 since we have a single odd and a single even in triangle and square. So that means that square cannot be a 5 because 5 plus either 2 or 4 is already greater. 3 is okay because you could always add it to 2, and 1 is okay because you could add it to 2 and 4. Okay, let's see. That said, if I were to pick a 1 for square, that is true that the sum of triangle and square would be, well, let's do this. Again, let's talk about which square or triangle would be the largest. Well, square 1 cannot be the largest because then there's nothing to pick for triangle and circle. So let's say that square is 3. So if square were the largest, then it would be 3. And then I guess it could be 2, 3, 1. That's possible. Let's actually type that out. We'll say that 2, 3, 1 is a possible solution where square is the largest. And that's the only possibility where square could be the largest. Okay, now what about triangle? Well, triangle 2, well, we haven't established how many ones there are. Could it be 2, 1, 1? I guess that is a possibility. Nothing to preclude that. Okay. And then what about 4? Well, I guess if 4 is the largest in triangle, then what could we have? I guess you would have to again pick 1 in square for 1. And I guess you could have 1, 1, 4, 1, 1, 4, 1, 3, 4, 1. Oh, yeah, and 4, 1, 3. 4, 1, 1. Oops. And then 4, 1, 3. Because triangle would still be the largest. Okay. So I think that maybe the middle 2 would be ambiguous because both of them have triangle the largest, either 2 or 4, and they both have 2 1s. It's the largest, it's even, you have 1 even, and the sum is less than 6. So yes, I think we can eliminate these 2 as being ambiguous. And it's down to 2, 3, 1 or 4, 1, 3. They both, so it seems like maybe we can deduce that there can be a single 1. Yeah, I think we can deduce that there's going to be a single 1. And then the question is, well, which one is the largest? Is it triangle or square? So let's go ahead. I'm going to type in B that we're going to deduce that the solution has a single 1. And then we'll test, we'll test C again to see which one is the largest. And so let's go ahead and test C. Okay, so it is true. If you look at my proposal, I did pick, or the largest in my proposal is the triangle digit, and the Turing Machine confirms. So let's go ahead and cross out the OR, including the square. And so triangle is the largest. So what does that mean? So out of those 2 solutions, it would be 4, 1, 3. Yeah. Well, let's see. Yeah, I'm pretty sure I was a little hesitant about why can't it be 2, 1, 1 because, well, triangle could be 4 and it still could be 1, 1. Yeah, that makes sense. So it must be 4, 1, 3 based on sort of the deductions and process of elimination. So we'll say 4, 1, 3. And so let's, and of course it can't be a 5, too big. So it looks like our solution is 4, 1, 3. Let's type it up. And so let's do a quick review here. Is the first digit even? It sure is. We did deduce that there should be only a single 1 based on what available potential solutions there were, and we eliminated the middle 2 for being ambiguous. They both had triangle the largest, and they both had 2 1s. And so there's no way to distinguish between them. And then we did conclude that triangle must be the largest. It is, and it's the only even, And the sum is less than 6. Yes. All right, well, let's go verify 413 as our solution. All right, fantastic. Yes, that's correct. Well, how do we do versus a Turing machine? Well, this is a 5 criteria card puzzle, and we did exactly 5 tests. We did test C twice, but we were able to outright deduce the number of ones criteria card B. So we did do ACD in the first round, and then CE in the second. And so let's type that up. So again, that was ACD and then CE. So it looked like AC, were they both wrong? I believe they were both wrong. Yeah, D was a correct one. And then C was correct in the second round. And then E was incorrect. So how do we do? Wow, fantastic. So we beat the Turing machine by 2 questions. Very interesting. I don't know how we kind of attributed that advantage. Again, in part, yeah, we were able to deduce criteria card B. I think we were also fortunate that once we determined that it was even, odd, criteria card F, we knew it could be a 6 or equal to 6. So, we were left with 2 possibilities. It was that 50-50. And so I think in part that was very helpful. And I think perhaps that's what did it. How about you? How did you solve it? What criteria cards did you choose? And did you discover anything interesting that you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.